Good morning, students. Today I will be starting the respiratory system physiology. So what is respiration? The respiration is a process of exchange of gases between the atmosphere, blood and the cells of the body. That is the principal function of respiratory system. And the other functions are filters the inspired air, that is when the air is inhaled, that is filtered in the respiratory system, and it houses the sense organs for smell. So smell is a special sense which is housed in the nose, and it also functions for sound production, and it has three basic steps: pulmonary ventilation or breathing, and external respiration or pulmonary respiration, and internal or tissue respiration. So the pulmonary ventilation or breathing includes inspiration, that is inflow, and expiration or outflow of air between the air spaces of the lungs. So you can see here in this picture, inhalation is inflow and exhalation is airflow of air between the air spaces of the lungs. And the external or pulmonary respiration involve exchange of gases between the air spaces of the lung and blood in the pulmonary capillaries. Okay, so exchange of gases between the air spaces of the lungs and the blood in the pulmonary capillaries, that is external respiration. The pulmonary capillary blood gains oxygen and loses carbon dioxide to the air in the alveoli. Okay, so the capillaries gain oxygen and loses carbon dioxide to the air in the alveoli. So this is the picture. You can see bronchiole with alveoli. This is the site of external respiration, the exchange of gases between the alveoli and blood capillaries. So external respiration reactions are Hb plus O2 combines to form HbO2, and HbCO2 will dissociate to hemoglobin plus CO2. CO2 escapes into the air. So hydrogen ion combines with bicarbonate to form H2CO3, which will again dissociate to H2O and CO2. This is a bronchiole with alveoli, which is the site of external respiration. The internal or tissue respiration is the exchange of gases between the blood in systemic capillaries and tissue cells. So in the blood, it loses oxygen and gains carbon dioxide. And in the cells of the body, the metabolic reactions consume oxygen and gives off carbon dioxide during the production of ATP. So that is called cellular respiration. In the cells, oxygen is produced. So that carbon dioxide is produced, which is gained by the blood. And the blood gives off oxygen, which is consumed by the cells. So that is called cellular or internal tissue respiration. So now we will see the parts of the respiratory system. The first one is nose. What are the functions of the nose? It warms, moistens and filters the air from the nasal hairs. And olfaction, that is the nose has olfactory receptors which houses the sense of smell. And sound production or speech, the large hollow resonating chambers modify speech sounds, that is it has superior, middle and inferior nasal conchae or turbinates, which are lined with mucous membrane containing goblet cells and is vascular. And the next part is pharynx or throat. It is divided into three parts anatomically, that is nasopharynx, oropharynx and laryngopharynx. So in this picture you can see this is naso, this is oro and this is laryngopharynx. The nasopharynx is the superior portion of pharynx. It is lined by mucous membrane, pseudostratified columnar epithelium. It lies posterior to nasal cavity and extends to the plane of soft palate. It has 5 openings, 2 internal nares and 2 openings, eustachian auditory tubes, and 1 opening into oropharynx. The function of nasopharynx is respiration. Also exchange small amount of air with auditory tubes to equalize air pressure between the pharynx and middle ear. It also contains pharyngeal tonsil. And the oropharynx is the intermediate portion lined by non-keratinized stratified squamous epithelium. It lies posterior to oral cavity and extends from soft palate inferiorly to the level of hyoid bone. It has only one opening, that is the fauces. Okay, so you can see only one opening, that is fauces. And the function is mainly respiratory and also digestive function. It contains palatine and lingual tonsils. So these are the palatine and lingual tonsils. It is a common pathway of air, food and drink. And the laryngopharynx is the inferior portion which is lined by non-keratinized stratified squamous epithelium. It begins at the level of hyoid bone and connects the esophagus with the larynx, that is voice box. And the function is again respiratory and digestive. Larynx. So it contains thyroid cartilage or Adam's apple and epiglottis whose function is preventing food from entering into larynx. Cricoid cartilage connects the larynx and trachea, and paired arytenoid cartilages, corniculate cartilages and cuneiform cartilages are present. And the vocal cords in the larynx produce sounds as they vibrate. So the main function of vocal cords is production of sound. That is, they become tense for high pitches and relax for low pitches. And it is also lined by again non-keratinized stratified squamous epithelium. And coming to the lungs, left lung is 10% smaller than the right lung. Right lung is thicker and broader and shorter than left lung. Diaphragm is higher on right side, accommodating the liver that lies inferior to it. The blood supply of the lungs are arteries and veins. Arteries carry oxygenated blood which enters via bronchial arteries, supplying the muscular walls of bronchi and bronchioles, and deoxygenated blood enters the lungs via pulmonary arteries. There are 4 pulmonary veins. Unique to the pulmonary circulation is the vasoconstriction of pulmonary blood vessels at hypoxia. And for circulation in other tissues, hypoxia causes vasodilation of blood vessels. The significance of this is it allows for ventilation perfusion coupling. That is, where ventilation is maximal in the lung, perfusion should also follow through maximally. And where ventilation in the lung is minimal, perfusion should also be reduced proportionately. This is to ensure efficient gas exchange. Maximal amount of oxygen is taken up by the pulmonary capillaries. And in the lungs, each bronchopulmonary segment consists of lobules, which contain lymphatics, arterioles, venules, terminal bronchioles, respiratory bronchioles, alveolar ducts, alveolar sacs and alveoli. The alveolar wall consists of type 1 and type 2 cells. Type 2 cells function is to secrete the surfactant. Surfactant function is to reduce the surface tension within the alveoli, preventing alveolar from collapsing during expiration. And the wall also consists of alveolar macrophages. Gas exchange occurs across the alveolar capillary membranes. Okay, so the alveolar wall consists of these cells, and each bronchopulmonary segment consists of lobules, which again contains the lymphatics, arterioles, venules, bronchioles, respiratory bronchioles, alveolar ducts, sacs and alveoli. The last part is alveoli. So the gas exchange occurs across the alveolar capillary membranes. So this is the bronchopulmonary segment. You can see bronchiole, and then this is the pulmonary artery branch, terminal bronchiole, respiratory bronchiole, and then alveolar duct, alveolar sac, alveoli. Okay. So from the alveoli, the capillary beds are arising, branch of pulmonary vein. So the respiration or exchange of gases occurs across the alveolar capillary membrane. So this is the alveolar capillary membrane. This side is alveolus, this side is capillary. So this is otherwise called respiratory membrane. So here you can see the alveolar epithelium containing the different types of cells, type 2, type 1, and the macrophages and the air space. So if you take a section of this alveoli, you can see the alveolo-capillary membrane from inside the alveolus to the outside. These are the different layers of the respiratory membrane. The alveolar fluid, alveolar epithelium, basement membrane of alveolar epithelium, interstitial space, basement membrane of the capillary endothelium, capillary endothelium, and then oxygen diffusion and diffusion of carbon dioxide, and then the red blood cells. These are the layers of the respiratory membrane. Coming to the pulmonary ventilation, it is defined as breathing, that is inspiration and expiration. The ventilation is nothing but inspiration and expiration. So the basic principle in the mechanics of breathing, that is pressure gradient must exist to cause the bulk flow of air between atmosphere and lungs. So bulk flow of air goes from area of high pressure to area of low pressure, that is inspiration and expiration. So during inspiration, the air goes from the atmosphere, that is high pressure area, into the lungs. And during expiration, air goes from the lungs into the atmosphere. So the main principle is bulk flow of air goes from area of high pressure to low pressure. So that is a pressure gradient must exist. So inspiration is defined as air moving down its pressure gradient from atmosphere into the lungs. So we need to make the lungs have low pressure than atmospheric pressure. So how the lungs achieve the low pressure? So you need to revise the Boyle's law from your intermediate, which shows the relationship between pressure and volume at constant temperature. So pressure is inversely proportional to volume at constant temperature. So to decrease the pressure in the lungs, we have to increase the lung volume. So this is actively done by expanding the thoracic cavity, which indirectly expands the lung volume using inspiratory muscles. So there are two main inspiratory muscles, external intercostal and diaphragm. The external intercostal muscle pulls the ribs superiorly and sternum anteriorly. That is, increase in the anterior posterior dimension of thoracic cavity. So it is supplied by intercostal nerve. It is regulated by medullary respiratory center in the reticular formation. It sets the rate of breathing by sending impulses that last 2 seconds to the external intercostal muscle via intercostal nerve. At contraction, it elevates the ribs, responsible for 25% of air that enters the lungs at normal quiet breathing. So how the muscles are contracted means by the medullary respiratory center sending impulses that last 2 seconds to the external intercostal. This during contraction it elevates the ribs, which is responsible for 25% of the air that enters the lungs at normal quiet breathing. And the diaphragm function is that when it contracts, it flattens and moves inferiorly. So this causes increase in the superior to inferior dimension of the thoracic cavity. The nerve supply is by phrenic nerve, and again it is also regulated by the medullary respiratory center. So it sets the rate of breathing by sending impulses that last 2 seconds to the diaphragm via phrenic nerve. The contraction of diaphragm is responsible for 75% of air entering the inspiration at rest. The diaphragm and external intercostal muscle contract at the same time. So external intercostal is responsible for 25% and diaphragm is responsible for 75% of air entering at the inspiration into the lungs. So you can see in this picture, end of expiration, the muscles of inspiration are involved, diaphragm is relaxed, and end of inspiration, labored breathing, additional muscles contract causing additional expansion of thorax. During quiet breathing, the external intercostal muscles contract, elevating the ribs and moving the sternum. And the abdominal muscles relax, diaphragm muscle contract, increasing the superior inferior dimension of thoracic cavity. and quiet breathing, that is the external intercostal muscle contract causing the anteroposterior diameter. This is pump handle mechanism of the expansion of the thoracic cavity. So, and the expiration, air is moving down the pressure gradient from the lungs into the atmosphere. It can be discussed in terms of quiet breathing and active breathing. During quiet breathing, it is an active process because no muscular contractions are involved. Inspiratory muscles relax and elastic recoil of chest wall and lungs occurs, and there is inward pull of surface tension due to film of alveolar fluid. How the inspiratory muscles are relaxed means external intercostal muscle relaxes, which causes the ribs moving inferiorly. Anteroposterior dimension of the thoracic cavity increases. Thus, diaphragm relaxes, which returns to its resting dome shape, which causes decreased superior-inferior dimension of the thoracic cavity. And during active breathing, which involves the recruitment of expiration muscles, the abdominal muscle contract moves the inferior ribs downwards, which compresses the abdominal viscerae, which forces the diaphragm superiorly. And the internal intercostal muscle also contracts, which pulls the ribs inferiorly. The active breathing occurs in labored breathing and conditions where air movement outside the lungs is impeded. And next, coming to the factors affecting pulmonary ventilation. There are surface tension of the alveolar fluid, compliance of the lungs, and airway resistance. Surface tension is a force exerted on the surface of liquids causing them to have skin-like effect. Surfactant reduces surface tension of alveolar fluid below the surface tension of pure water. Surfactant is a mixture of phospholipid and lipoproteins which are present in the alveolar fluid. Respiratory distress syndrome, that is deficiency of surfactant. Surface tension of alveolar fluid increases, so many alveoli collapse at the end of relaxation. So alveolar surface tension is produced by thin layer of alveolar fluid that lies next to the air in the alveoli. So in the alveoli, the next to the air, the line is thin layer of alveolar fluid, that is surfactant. It exerts a force known as surface tension. What is its significance? The alveolar fluid surrounding the alveolus produces surface tension, which is an inwardly directing force. So the role of surface tension at expiration. Alveolar surface tension is a major component of lung elastic recoil. It assists in decrease in the size of alveoli during expiration. Role of surface tension at inspiration. Alveolar surface tension is undesirable because it increases the work of inflating the alveolar. So therefore lungs needs to decrease alveolar surface tension at the inspiration. So alveolar surface tension makes inspiration difficult because the pressure is coming, air is coming inside. If the surface tension tries to decrease alveolar size, it will become difficult to fill the alveolar. That's why surface tension will be low during inspiration. And alveolar surface tension assists in expiration by allowing air out of the lungs. So surface tension helps in reducing or collapsing the alveoli so that air goes out of the alveolus. At inspiration, lungs need to decrease the alveolar surface tension. The function of surfactant is surface tension of the alveolar fluid. Net effect is decrease the tendency for complete collapse of alveoli at expiration. And the next one is compliance of lung. It refers to how effort is required to stretch the lungs and chest wall. That is, high compliance means lungs and chest expand easily. It is related to two factors, elasticity and surface tension. Lungs have high compliance if elastic fibers in lungs are easily stretched, and surfactant in the alveolar fluid reduces surface tension. Compliance is defined as the ease at which lungs and thoracic wall can be expanded. High compliance means their lungs and thoracic wall can expand easily, and low compliance means they resist the expansion. And factors that influence compliance are elasticity and surface tension. And conditions that decrease compliance: scarred lung tissue like tuberculosis, lungs filled with fluid like pulmonary edema, and deficiency of surfactant, and conditions that impede lung expansion. Examples: paralysis of phrenic and intercostal nerves. So all these conditions decrease the lung compliance. Airway resistance. It describes the relationship of airflow velocity in airways to airway resistance. So airflow velocity is equal to alveolar pressure minus atmospheric pressure divided by airway resistance. That is, when airway resistance is increased, which will cause decreased airflow velocity. So factors that affect the resistance. Breathing. Increasing thoracic cavity size leads to increasing lung volume. The airway radius increases, which causes decreased airway resistance, leading to increased airflow velocity and volume of the lungs. And reverse of the above occurs during expiration. Decrease the airflow velocity and volume. Degree of contraction, that is relaxation of smooth muscle of airways. When the sympathetic stimulation increases, the beta adrenergic receptor types acts, relaxation of airway smooth muscle occurs, which leads to bronchodilation, and therefore the airflow resistance decreases. Conditions that obstruct or narrow the airway resistance. The more pressure is needed to force air out. Activities where there is forced expiration like coughing, playing a wind instrument. The forced expiration leads to increased intrapleural pressure, increased airways causing compression, and therefore the airway resistance is increased. And COPD, that is chronic obstructive pulmonary disease, emphysema and bronchial asthma, which causes increased airway resistance. So in these conditions, that is activities where there is forced expiration and also diseased conditions like COPD, there is increased airway resistance. The rate of airflow through the airway depends upon pressure difference. Airflow is influenced by pressure difference between the atmosphere and alveoli pressure. And resistance, wall of the airways, especially bronchioles, offer resistance to normal flow of air into and out of lungs. Large diameter airways, the air flows freely through the airways when compared to the narrower airway. So narrower airway increases resistance to airflow. Example, asthma and COPD, which increase the airway resistance. And lastly, the breathing patterns. If you see, there are various breathing patterns. The first one is eupnea, which is a normal, quiet breathing, shallow and deep breathing combined. Apnea is a temporary cessation of breathing. Dyspnea is painful or labored breathing or difficult breathing. Tachypnea is rapid breathing where the respiration rate is increased. Coastal or shallow breathing. It is named after chest breathing where there is an upward and outward movement of chest due to contraction of external intercostal muscles. Diaphragmatic or deep breathing. Deep breathing that is due to outward movement of abdomen due to contraction and descent of the diaphragm. So these are all the various breathing patterns. So during inspiration, to summarize the topic, during inspiration the pressure inside is low and the pressure outside is high. So that's why, because of the pressure gradient, during inspiration airflow occurs into the lungs. During expiration reverse happens. So you need to know little bit about the different pressures in the lungs. And also you need to know the mechanics of respiration. What are the things happening or events happening during inspiration and during expiration, and also about the surface tension, compliance, and the airway resistance. So that's all. This completes the introduction, that is the respiratory system functions and also the mechanics of respiration. So thank you all.